Today, we're going to electrify our potato cannon. And more than that, it's not just going to be a potato cannon anymore, it's going to be a super Nerf cannon. You'll see. Today, we have a special guest here, Augusto, who's from Londrina, a physics teacher, and he's gonna give me a hand today. Everything good?
For sure, man.
Are you ready to fire some potato cannon shots?
Absolutely! It's an honor. I was inspired by this cannon to build one with my students. Now, I get to see it up close.
It's gonna be really cool, man. This potato cannon has a wild story. We built it 14 years ago and received many emails from people wanting it as a gift. Everybody wanted to have this thing because it's really cool. So we decided to hold a contest. It was the Liquid Tower contest. Whoever managed to stack the most different liquids would win the potato cannon. And Mari and I made a crazy promise. We would deliver the potato cannon wherever the person was in the world. If someone from Portugal or Mozambique won, we would go there to deliver it. We were lucky. The cannon winner was from a city near Ribeirão Preto. Do you know which one? Batatais. Yes, the person who won the potato cannon lived in Batatais. It was Alexandra. He was 15 years old. So, Mari and I took our little silver Celta and went to Batatai to deliver the potato cannon to Alexandra. We took the opportunity and recorded a video there explaining how it is, making fake glasses, and this story could have ended there. Now, in 2024 Brasilia, I went to give a lecture at campus party in Brasilia, and after the lecture, I went to have dinner with some friends at a restaurant near the hotel. After it ended, I chose to walk from the restaurant to the hotel. Walking in an unfamiliar city can be a bit scary. It was about 3 or 4 blocks, really close, but you never know, right? Who knows if the place is dangerous or not? While crossing the street, a tall, long-haired man, much bigger than me, approached from a distance. My heart froze. Then the guy said, Ibaré, Ibaré. Well, if he recognized me, there's less chance he'd want to rob me at night in Brasilia, right? Then he said, Ibaré, I'm Alexandra, the guy who won the Liquid Tower contest. I looked at him and said, no way, you're not Alexandra, you're making that up. There's no way there would be such a coincidence. Me running into Alexandra like that 14 years later, walking in Brasilia. I said, prove it, prove you're Alexandra. So, guys, he pulled the potato cannon out of his pocket. No, just kidding, that's not what happened. Then he said, we recorded the glass video, the fake one. I showed you a lava lamp I made there, with fluorescent paint. Some 3,000, 5,000 piece puzzles that the whole family would do together. His little brother was there. It was Alexandra himself. He was already 29 years old, studying physics and working at Campus Party at a RoboCore booth, a robotics company from Sao Paulo. So Alexandra, let's build this potato cannon now. Next time, we can try firing the electric version. Deal? First, Augusto. Let's test this, since it's not the original. It's not the one we gave Alexandra, but the one we made about 2 years later. It's already old.
It's dusty, right?
Yeah, it's disgusting. Actually, some mold has grown here. But I think we should try filling it up to see if it leaks. Okay, how does this work? We close this valve, fill it with air inside using a car tire pump. When we open it, all the air rushes out at once. Can I pump it? Let's try. I'm turning it here to see what happens. Go ahead.
It's good, huh?
Let's test it with a potato. Put it in, see, it gets stuck here. I pump, you release, and shoot, even at the ceiling.
I was going to ask you to shoot me, do you think?
Shoot you?
Yeah, shall we try it?
Man, you're brave. But hold on. Are you the one who's going to put it in, aren't you? Protection is required. 3 strong pumps. Ready? That was really weak, huh? We've already seen here that the problem is this valve. And the idea of this video was exactly to replace this valve with an electric one. It was a problem from the very beginning. Using it frequently causes wear. Water can seal it, but air leaks and shoots out the projectile. So let's replace this with something electric. The electric valve is this. It's called a solenoid valve. Basically, it's an electromagnet that, when it gets electric power, pulls a piece of iron and opens the faucet. The only problem is that this is 110 volts. It doesn't work with batteries, so we'll have to make something that works kind of plugged into the outlet. So we'll have an electric cannon with a tail like this.
Take out this mechanical part here.
Replace the mechanical part with the electric one. I'm not sure it's fully sealed. When I blow on it, it seems sealed, but the pressure isn't the same, right? I don't have the same strength here, and I don't know if it'll open all at once when it does.
This is what we used in that first automatic watering video we made here on Manual do Mundo. Let's test it out there. Wow!
Oh, the little sound.
That's what we need, right?
And what we wanted, right? Let's go. Now we need to install this here on the cannon. What we're going to install now is this here. Look, we use 2 threads to screw the solenoid onto the cannon's outlet. There's this PVC cutter here, which cuts exactly at 90 degrees. This tool is cool because it has a little wheel that goes around the pipe and tightens it. The soft PVC pipe bends and eventually it cuts. And then you can adjust the tightness on this nut here with this little wrench. So, check this out. This thing looks like a pizza cutter, and it tightens the pipe. It's essential for frequent PVC pipe users.
Copper pipes too, right?
Wow, copper pipe? Look at the finish here. Ah, this won't, it fit. And the PVC glue kind of welds it, right? It bonds plastic to plastic in a way that it never comes apart. Now, we have to install the solenoid onto the threads here. I'm going to apply thread seal tape, which is a tape that covers the threads and prevents water or air from leaking. There's a thread sealant glue, right? The Tech Bond liquid thread sealant they sent us. I don't know where I put it. So let's just use the thread seal tape then. There's a right side, because when you screw it in, you tend to take off the thread seal tape.
I got it. In the direction of the turn.
That's it. In the direction of the turn. If you put it on the right side, you comb instead of pulling it out. You get it? You smooth it out.
It happened to me too. It turns into little strands, right?
It turns into a mess. Another thing I do when putting on the thread seal tape is to put just a little at the start of the thread and more at the end, because that way you can start the thread easily, and it gets harder as you go. Look, here it's easy. Then, as you get to the end, it gets a lot more resistance. But that's a sign that it's sealing 100%. We can already test at least if the electric part works. Let's go. Wow.
Now I'm scared of getting shot by one of these.
This thing just went to another level here. Can you do it one more time so we can see?
You increased the caliber, huh?
This thing is long. Press here because I can't, my shoulder won't let me. Please. Done. It was 1, 2, 3. It's a cannon from another generation. It's from another generation. Man, that's amazing. Yeah, now it worked. And the potato was loose. Yeah, it was loose.
You see, so you held it well, right?
You held it. This part of the solenoid here is very fragile, and the pipe in front gets loose. It bends, and I think it will break soon. We need to add some reinforcement down here, so this stays straight and secure. I'm already printing some supports on the 3D printer. I don't know if it's worth doing it on the 3D printer. Maybe it's too fancy, but we could already make a reinforcement without a trigger, right? But there's one thing I wanted to do first, which is this. It's not portable at all. We need to plug it in for it to work. Ideally, we should have electric power in the cannon itself. The issue is, it's 110 volts. We don't have a 110 volt battery or a transformer to convert 1.5 volts to 110. That's complicated. I have a kind of crazy idea. Let's see if it makes sense. Here's the idea. I'll use the motor that spins the microwave plate as a generator. It's cool because if you spin it, it generates 110 volts. The problem is that it can't activate the solenoid, right, our electric valve, just by giving it a little spin. It doesn't generate much energy. It produces few amperes, little current. So I have to store this energy somewhere. The best place to do that is in a capacitor. A capacitor is like a battery that can quickly store and release energy. So after this capacitor, then I can send it here to the solenoid valve, right? To our electric valve. But there are 2 points. First, I need a diode here. A diode only lets energy flow one way and blocks it from coming back, because otherwise the capacitor will discharge its energy into the microwave motor here and make the motor run. I don't want the motor to run, just to generate energy, always sending it from here to there, never from there to here. There's one more thing I forgot. It's that I need at some point to put the switch here, the little switch here, so it doesn't discharge the energy as soon as I turn the motor. So I charge the battery, I charge the capacitor, Then, when I want to shoot, I close this switch here. The solenoid opens, releasing the air. In our stock here, we have a 1IN4007 diode. If we burn it out and it goes wrong, each one costs 9 cents. That's a serious loss here, huh? It can handle up to 1,000 volts, according to what's written here. So, no worries, we'll never reach that. The power has to go from the black to the silver. We'll have to make a little circuit here and test if it works now, right? Let's charge this thing to C. Sure. I think we could short circuit it later to make a zap, you know? See what happens. It's hard to turn the little motor here, the shaft of the microwave motor. Now, we need to see if this spark is enough to activate the thing. But now, I have a question. I don't know if it's on or off. Let's just plug it in here to see. We have to leave it on, right? Man, it's not for nothing. Our little project here, man, involves mechanical stuff, electrical stuff. Pressure, it's all here. This small item teaches a lesson. Now, it's simple. We need to put this together in a usable way, right? Ergonomic, right? It needs to be ergonomic. It needs to have a way to spin this nicely. We need to think about what to do, but it works.
It worked.
It works. Let's test the potato like this. Otherwise, we may think it's working when it's not. For example, a loose potato is actually harder to shoot, so you have to load the thing. It's on. Then, we also have to figure out how many turns we need to give the engine for it to load enough. For example, the air here. We know that 60 pounds per square inch is enough. Jansen's already scared of getting hit by a potato. Okay, here we go.
Now it's working.
Man, that's amazing. That's amazing. Here we survive a zombie apocalypse. There's no problem at all, man. Look, here's my idea. Place something here with the trigger for the person to shoot. A switch we still need to install. That's the only thing missing in this circuit. Then, thinking that it will be here like this, you could turn here and shoot here. Let's draw this, right? Now comes a part I really like, drawing to eventually turn the idea into reality. First, we'll make the clamps that attach to the PVC pipe. These will be sent to the 3D printer. And then I need to draw the handle, and the part where the crank that generates energy will be. This is where we'll hold it, like a shotgun handle. And it'll be made with the laser. The cool thing about what we're doing here is that it's a whole little system that fits the pieces together with a lot of precision. And the coolest part of all is that all the electrical components will be built inside the handle itself. Now, look how beautiful this little thing is here.
Perfect.
Yeah, man. This is it. We mess up sometimes, but there are things we enjoy doing well too. I think we should test it now, don't you? This burr keeps the pipe in place. Here's the crank end. I'll turn it, so this must stay loose for my hand to slide.
Wow, this is so professional. 14 years ago, Ibere would be proud.
Yeah, he would. We've improved over the last 14 years, huh? Not to brag. Now, let's put the switch here.
Let's go.
And then we'll put a nut, a little washer, and the nuts. It's not working. Something went wrong.
Let's open it.
We'll have to open it. Ah, 2 hours later, it's all organized, see? The wires run here and will be covered. It's not insulated here because it's unnecessary. It'll be covered, like in an electronic device, where not everything inside is insulated. Anyway, and here are the 2 wires that go out to activate the solenoid. The switch didn't fit in the space it needed. Now we're going to have to glue a little plate on top because it became dangerous. There are wires showing here on the switch, so we're going to have to protect it.
Imagine accidentally bumping your finger there.
Wow, you'd get a serious shock here. Go. The electrical mechanism is working here. The last task now is to attach this electrical assembly to the cannon. We've already 3D printed these small clamps. Now we just need to install them, at least in theory.
Final stretch, right? Oh, there's a little noise.
Borave the accuracy of your drill here, huh? Oh, Augusto. You have to fit it in here, huh? Look, didn't it fit? Look at that. Hey, we didn't count on this. It's hitting the screw there. We'll have to shave the plastic a little. Look at the design flaw here. It's hitting right on top of this screw. So I'm going to mark it with chalk so we know exactly where we need to sand down. Man, I hadn't thought of that, right? You can spin it with your right hand and shoot with your left hand. Wow, I should have put the crank on the other side. You crank with one hand and shoot with the other, because this way you'll have to crank.
You have to keep pumping it, right, Ibare?
We just need to finish the electrical connection here, huh? Let's do it. Let's remove this cable, which was the test cable. It's ready. Looks good, my friend. Just look. One very important note for anyone doing this. The capacitor holds a lot of energy and can deliver a strong shock, but we didn't get shocked. In the end, everything must be well insulated to prevent anyone from touching the capacitor and getting shocked. Now, look. Let's see if it will open when we... I didn't even know there was pressure inside. Try it with the potato.
Let's go.
I don't have the shoulder strength to make this potato. Let's go. 60 pounds. That's another thing too. If you're going to do it, don't put more than that, because it can burst the PVC here. Is Jansen afraid of taking this shot now? Yeah, now it's just a matter of pressing a button, right? It's different.
Let's test it again now. We started the video and it wasn't that elaborate, right?
The guy is brave.
This is the Manual do Mundo channel, right?
This is another thing you shouldn't do at home, okay? Just to make it clear, this is going to leave a bruise.
Ibare, move back a little bit.
Distance doesn't matter, man. 1, 2, 3, and...
Now it was stronger.
Man, now it sounds cool. Now, it's not unloading everything at once. Look, if I give it a spin here and press the button again, it stores a lot. You can fire multiple shots. Borave how many it takes. Look, third shot, bang. And it's still strong, still strong. Fourth shot, bang. Yeah, this shows that the one we opened at the valve was wasting a lot of air. Bang. Fifth shot without reloading. This is much better here. Bang. Careful, are you eating that potato? 6 shots, 7 shots. Oh my goodness, look at that. I didn't expect that. What's going on? The solenoid opens and closes really fast, so there's not enough time for all the air to escape. And then we can fire several shots. How many was that? 7, 8. It's already weak. 9 shots isn't much. Let's try for a 10th so we can call it a 10-shot gun. That one was really cool, man. Alright, let's make a Nerf tip. Let's go. A big Nerf tip now, to make this thing even cooler. How did I come up with big Nerf? Look, there's this pool noodle, this pool spaghetti, which is already made of the same material as Nerf, just way bigger. And then I already drew a tip here, which is what will give it inertia.
It has to fit just right, right?
Look, it fits just right. Wow, this is going to be really cool. And now we need to remove this support here from the 3D print. Look how nice it is. It was already designed to fit here. You don't even need to glue it, really. But let's glue it just to be sure, right? It was made with a lot of filament, so it would be heavy. Let's put some glue here and some glue around here. Do you want to try it?
Let's go.
3, 2, 1.
No, one more time, look.
How weak. I think the problem that's happening is that the Nerf doesn't fit snugly here in the barrel. It goes in with extra space. When the air is released, half escapes. Let's try mixing potato with Nerf.
3, 2, 1.
Wow, did you see the commotion? Now.
Yeah, now.
Oops, the mushroom came off from this thing.
It's because the potato went through the pipe and hit the tip.
Oh, of course. The potato hit here. Yeah,
Collisions?
that was intense, but that shot was way cooler. We're thinking about sticking a cork here at the tip, inside the Nerf, to see if it seals better and releases all at once. But let's test it first just with the cork, right?
3, 2, 1.
Wow. Man, it's way better than the potato. Let's try to stick this here on the Nerf, right here.
Let's go.
Do you think it'll fit in there properly? It will, right? Well, now it's the Nerf cork.
3, 2, 1, and... I got it.
Now that's it. Let's shoot outside to see if it goes far, okay?
Let's go.
Hey, don't fill it that much. How much is in there?
Relax. Look, 60.
No, that's good, that's good. That's it. Here you go. It's more or less. Yeah, like a Nerf, right? It doesn't go far. Let's try again, okay? It's better now, huh? It's already getting cool here. Wow, the cork works way better than the Nerf. It barely curved downward. I think we can have some fun target practice here, huh? But we lost the cork because it disappeared into the bushes. You can't see from there, but there's an audience behind you. Set up a target. This looks like that candy that's shaped like an eye. You know? Everything's kind of messed up. I don't know. Look at the state of the target. Even.
Odd.
I won. I'll start.
Let's go.
Let's go.
Go, go.
Wow. Completely wrong. Passed.
Right. The glasses got in the way. What can you do?
Are you blaming the safety glasses? Well, at least you hit the paper, right?
You made a hole, right? Who scored more points?
I lost, right? I lost this expert shooters competition. Look, we hit right there, in the middle of the target.
I think it should be fair. I took a lot of shots in this video, so you should let me shoot you once to finish.
Look, all right, right? What can I do?
Where's the cork?
I don't know. The cork got lost. Now the cork disappeared. Hey,
This is going to be my revenge.
if you miss the shot, you only get one shot, okay? It's a one-time chance. It hit the shirt? I didn't even feel it.
But it was worth it, huh?
Oh, but it's weak. Seriously, the cork is really weak. It's not a dangerous shot or anything, because it's very light. So it's not something whoever's watching. No. Sometimes people shoot with a clip. Yeah.
The noise gives you a scare.
The noise is startling. It's cool because it's fast, but it's a very light projectile. A gusto.
Thank you very much.
Thanks, man.
It was incredible to be in this video. Whoever wanted this beast 14 years ago.
Man, just to be clear, we didn't copy this project. We created it from scratch, and it turned out great.
It worked, right, man?
How do we find it on Instagram?
Augusto Riche 2Cs.
All right, let's take a few more shots. Alexandra is invited to Manuel de Mundo to fire the potato cannon 2.0 deal.